In this video, we'll discuss defining and reasoning with fractions. Now, a fraction occurs when we take and explore one or more parts of a single item or a collection of items that have been divided into pieces. When we write fractions, we write our numerator on the top, which is the number of parts we're examining, over our denominator, which is the name of the parts of the whole. For example, 3/5 would mean we're looking at 3 parts of a whole that's been split into 5 parts. Now, when we talk about unit fractions, this is when we're looking at one part of a whole that's been split into some number of parts. In this case, we'll call b. For example, 1/5 would mean we have one part of a whole that's been split into 5 equal pieces. Kind of like if we took a pizza, the unit fraction would be 1/5. So that'd be one slice of 5 slices that we have for the whole. Now, a key word there you'll hear me saying is the word of. And it's because we're talking about fractions in relation to the whole. So when we write or speak about fractions in relationship to an object, we're talking about the of part of the whole. It's how we're relating the fraction in that whole. For example, if I have a garden and I say 1/4 of the garden is corn, that means if I split my garden into 4 pieces, one of those pieces would be full of corn. I ate 1/12 of a brownie. I've got a whole brownie plate in front of me and I cut out 1/12 of it. We drank 5/12 of a soda case. Soda case has 12 cans and we've drank 5 of those. That's 5/12. 2/3 of the houses have a porch. So that means we have a collection of houses together, and of those we have, 2/3 of them have a porch attached to them. Now, when we talk about wholes, we have to pay attention again to the fact of whether we're talking about a single object or a collection of objects. A single object like a pizza or a brownie versus, say, cars in a parking lot or number of soda cans. Those are collections. So we have to always make sure that we're identifying what that whole is, even when we don't know what it is based on because it's not stated. So we need to figure it out. And when we look about equality of the whole, we have to think about context, because our equal parts could be different on the type of problem we ask. And here's an example. Here's my shape. Okay, if I split it into 3 equal parts, a lot of people will split it based on this diagram, where all 3 parts look exactly the same. They have the same perimeter and same area. However, if my instructions are not clear or my context is different and I'm only looking at area, it is possible for this third shape to also be a way of equally splitting my odd shape here, because the area of all 3 parts here is exactly the same. Now, we can also talk about improper fractions, and this happens when our numerator is greater than our denominator. And a lot of times when we're talking about in elementary school, we'll talk about changing that to a mixed number. And students still struggle a lot with the improper fraction because it's kind of hard to understand how to replicate more than one whole. So if I say 5/4 of a pie, that's more than my entire pie. They understand 4/4, but then they have to recognize that each of those are individual pieces, and I'm pulling over yet another piece of a different pie. So I've got 4 pieces making my whole pie and 1/4 of yet another pie. Now, context again is very important, because we look at this image and we have to ask ourselves, is this 7/8 where my whole is all the boxes, or is this 7/4 where a whole is represented by one rectangle? And the thing is, it depends. It's all about that context. If I say that my whole is everything in the picture, I have 7 of the 8 pieces shaded in. But if I say that my whole is just one line here, that's 4 out of 4 plus 3 out of 4. In other words, 7 parts if my whole was 4. Think about those candy bars. I've got 2 candy bars. I've got a whole candy bar and 3/4 of the other one. 1 3/4 or 7/4. Last thing we'll talk about is the notion of how we relate fractions to number lines. And the important component to this is that our tick marks are always equidistant and based on the denominator. So if I have 3/7, I know that if I make a number line each piece will be 1/7 apart because that's the parts I've split my denominator into. So I've got 0, 1/7, 2/7, 3/7, 4, 5, 6, 7/7, and 8/7. Now when I get to my improper fractions, a lot of times we may go in and change those. So 7/7 represents 1 whole. 8/7 represents 1 and 1/7. Now I want to plot 3/7 on there. I'm starting at the number 0. 1/7, 2/7, 3/7, and that's where I plot it.